Welcome to Study Loop.
For part A of our question, we are asked to look at the table 33.4 to figure out for part A the type of mirror that is used. So to do that, just looking at it, we can see that this is a concave mirror. So concave mirrors, the way I think about it, is they kind of cave inwards. So I'll just draw it something like this. See how it caves in? I call that concave. Convex would kind of jut out like that. So just based upon that, we can say that this is a concave mirror. So part B wants to know what the focal length of that concave mirror is. Well, just looking at that and knowing that the focal length of a concave mirror is positive, the focal length is equal to 20 centimeters. We can box that in as our solution for part B. Part C wants us to calculate the radius of curvature of this mirror. So by definition, the radius of curvature is equal to 2 times the focal length. So 2 times 20 centimeters is equal to 40 centimeters. Part D wants us to look at the situation and figure out the distance to the image, or excuse me, the distance from the object to the mirror. So from this situation, we see the distance to from the object to the mirror is 10 centimeters. So P is equal to 10 centimeters, especially because it's on the left side, it'll be positive. Part E wants us to find the distance to the image using the information we now have. So 1 over the distance to the image plus 1 over the distance to the object, P, is equal to 1 over the focal length, F. We can rearrange this equation to solve for I. We find that I is equal to P times F divided by P minus F. So plugging the values for P and F into this expression, we find that I is equal to negative 20 centimeters, which we can box in as our solution for part E. Part F, we'll get a new page going here. Part F wants us to calculate the magnification of this image. So by definition, M, magnification, is equal to negative I divided by P. And make sure you plug in the negative signs if I or P is negative. And in this case, I is negative. So this comes out to equal 2. And that's a positive 2. Part G wants to know if the image that is produced is real or virtual. So to figure that out, we can go back to part E, and we see that I is negative. So since I is negative, it is on the opposite side of the mirror, so it's virtual. So we can say since I is negative, the image is virtual. And we can box that in as our solution to part G. H wants to know if the image that is produced is upright or inverted. So to figure that out, we can look at the magnification. And since the magnification M is positive, the image is upright. And then the last part is part I. We can work that out over here. It wants to know if the image that is produced is real. Or excuse me, it wants to know if the image that is produced is on the same side as the object that produced the image or the opposite. But since the image is virtual, it is on the opposite side. That's because these are mirrors. If it was a lens, a virtual image would mean it's on the same side, but it's a mirror, so a virtual image means it's on the opposite side.